For this next video, we're going to keep looking at parts of a circle, but instead of looking at the arc length around the circle, which we called S, we're going to look at the space inside the circle. We call that the area of a sector. Sector basically just means a pi wedge. So we'll call this area A, because hey, why not? And to find the formula for A, we're going to use a similar idea that we looked at in that sketch of the circle before. We're going to compare the part over the whole, an old trick from way back in Algebra 1. We'll compare the part over whole of the angle, so the central angle there is theta. The whole trip around the circle would be 2 pi. And we are going to say that that has to be equal to the other part over the whole. This is called a proportion. One part over the whole should equal the other part over the whole of the area of that sector divided by the area of the entire circle, which we know from a very long time ago is pi r squared. Well, I can solve this for A. Just multiply both sides by pi r squared. A equals pi r squared theta over 2 pi. And we can cancel a little bit of that out. The pi's cancel out. Nothing else does though. So that's just how our formula is left. I'm going to write it as a 1/2 instead of an over 2, only because that's the way I like to say it. You can certainly write that as r squared theta over 2 also, but I like to say it, and you'll hear it more commonly as the area of a sector is equal to 1/2 r squared theta. With one important catch again, and that is that this theta here is measured in radians, not in degrees. Okay, so let's try and answer the question that's here. Thomas cut a slice out of cherry pie from a dish with a 9-inch radius. So there we go, 9 inches. If the angle was 50 degrees, how much pie did he eat? How much pie means what is the area of the pie, because that's how you measure how much pie was eaten. I mean, sure, if we knew how much it weighed, maybe, or its mass or something like that, we could measure it that way. But generally speaking, when you talk about how much food you eat, you're talking about area or volume if we know how deep it is, but we don't. So we're going to use the formula for 1/2 for sector area, 1/2 r squared theta, to find out how much pie he ate. 1/2 times the radius squared times theta. But hopefully you've noticed the problem here, which is that I just told you that the theta has to be in radians, and then here I go trying to put it in degrees. Well, don't worry about that. We can fix that really quickly because we know how to convert from degrees to radians. And instead of doing it separately, we can just bake it right into the formula. If you ever have a formula that uses radians and you're given an angle in degrees, just while you're in the middle of the formula, convert it. We know how to convert from 50 degrees to radians. Multiply by pi radians over 180 degrees. And now we'll just do whatever simplifying and canceling we can. Let's see. The degrees cancel. That's an important start. 50 over 180, we can cancel out those zeros. Make our numbers a little bit more manageable. We've got 9 squared in the numerator, 18 in the denominator. Well, one of those 9's can cancel out part of the 18 and make it a 2. And if I take a look at everything that's left, because there's no more canceling left to do, I can say that this area is, in the numerator, I've got a 9 and a 5 and a pi. That's 45 pi. In the denominator, I've got a couple of 2's. So 45 pi over 4. But I do want to make sure you think about units of measure. If the nice thing about units of measure is that area can only be measured in one type of unit. It's a square unit. So if we know that the radius was given in inches, That means the area must be in square inches. And please read this as square inches, not inches squared. If you're ever not sure about that, the other thing you can do is just put the inches into the math. If you put the little inch symbol here, because that's the radius was actually 9 inches, not just 9. Well, remember, we are squaring that. So it looks like we canceled out the square, but that was just from squaring the 9. We're still squaring the inches, and that's where the square inches comes from. And that is the area of pi that he ate. Again, that pi has nothing to do with angles. It doesn't mean 45 semicircles divided by 4. It doesn't work that way at all. So if you want to convert that to a decimal, you certainly can. 45 pi over 4, that's about 35 and change square inches. So that's about 35.3 square inches. I certainly like numbers when they're exact, but it's nice to be able to turn it into a rounded decimal if we needed to compare it to how much pi somebody else ate from a different size pie. I don't know. The next question, one last example here, is similar to what we did with the arc length. We can kind of be given information from different parts of the formula and solve to find the missing parts wherever they are. So in this case, a farmer has the seeds to plant 1/4 square kilometer of soybeans. This 1/4 square kilometer is an area. She will be planting in a circular field watered using central pivot irrigation. If any of you have ever flown over farmland, you notice that a lot of farmland these days is circular. And this is why. Because farmland in a dry place that needs irrigation, instead of digging ditches throughout the fields, a lot of times what they do now is they have a pipe that has a pivot in the middle, and it just spins around very slowly in a circle. Very slowly, constantly watering the field below it. And that's how the field gets water, and that's why the field is a circle. So she'll be using a pipe that can rotate 4/5 of the way around a circle. So what we're telling you here is that the pipe, which is just a long rectangle, can rotate 4/5 of the way around a circle. This is realistic, actually. A lot of times the pipe can't go all the way in a full circle. The machinery to design it to go all the way around would actually be more complicated. So what they do is they have it go most of the way around, and that's how much of the field they can plant. And if we know that she has enough seeds for 1/4 square kilometer of soybeans, that means that this area needs to be 1/4 of a square kilometer. And the central angle would be 4/5 of the way around a circle. So again, we saw this with the arc length before. You've got to be careful reading this. It's the central angle is not 4/5 of a radian. It's not 4/5 pi. It is 4/5 of an entire circle. That's of 2 pi radians, which I would write as 8/5 pi. If you want to write that as 8 pi over 5, that's fine too. So what we need to figure out now is what length of pipe. Well, that's this distance right here. That's the radius. That's what we're looking for here. How long does the pipe need to be? We don't want to make it too long so that it's spinning around too much, more than what she has seeds to fill, because then, first of all, it's expensive. The pipes are very expensive. The longer the pipe, the more she has to pay. But also, if it's covering more area than she has seeds for, then she's wasting water. So she really does want to use just the perfect length of pipe. So we've got our formula for this. Area equals 1/2 r squared theta. And so we can just fill in what we know. We know her area is 1/4 of a square kilometer. And again, you can choose to use units the entire time, Or you can just always think about what kind of units fit the final answer. So that's the way I usually think. But if you want to put the square kilometers in there, if it helps you, be my guest. Equals 1/2 the unknown radius that we're looking for times 8/5 pi. So I can reduce that right side a little bit. 8/5 times 1/2 is 4/5. And our job is to solve for r here. So I'll just, move everything that's with the r over to the other side. The 5 goes into the numerator. The 4 and the pi join the other 4 in the denominator. And so the r squared needs to equal 5/16 pi. And so the r itself needs to be the square root of 5/16 pi, which you certainly could reduce the square root of 16 to a 4. But that doesn't mean the pi comes out of the square root. So root 5 over 4 root pi, which if you could try and rationalize that denominator, but I would tell you that you're not going to rationalize it. If there's a pi in the denominator, it's going to be irrational anyway. So I don't really care if it's irrational inside of a radical or irrational outside of a radical. I think it's fine the way it is. But if you wanted to, you could certainly multiply that by root pi over root pi to get the square root of 5 pi over 4 pi outside of the radical, if you think that's prettier. But let's just quickly think about the units of measure here. Remember, these were square kilometers, and then we took the square root of it, which means that these are measured in kilometers. Which makes sense because a radius should be measured in a unit of length. Be careful though, the problem did ask for the exact answer and also rounded to the nearest meter. So if it's rounded to the nearest meter, just be careful. You can certainly just type it into Desmos as the square root of 5 pi over 4 pi. But remember that those are measured in kilometers. So if a question asks you for in meters and your answer is in kilometers, let's multiply by 1,000. And so we can see that's 315.39, which round to the nearest meter would be 315 meters.